Hi, welcome to Nomis Academy. In this video, we are going to consider stationary points under the application of differentiation. The first thing we like to do is to define stationary points. Now, a stationary point, or we say a point on a curve at which the y, the x is equal to 0 is called stationary points. Alright, now we would like to know the different type of stationary points. Okay, any point where the y, the x equals 0, that particular point is called a stationary point. Now we have different types of stationary points. The first one, types, they include one, we have maximum points. Two, we have minimum points. And three, we have points of inflation. Okay, these are the basic or the three major stationary points we have on a curve. Alright, bear in mind that at these points, the y, the x is equal to 0. In the course of the discussion, I'm going to explain the nature of this type of point. Now let's take a graph. Okay, this is the y-axis and this is the x-axis. Now when you have a curve going like this, okay, at this peak here, there is a point. We draw a horizontal line that is parallel to the x-axis, and then let's call this point point A. Then also somewhere here, you also have a point. You can draw a horizontal line that is parallel to the x-axis, and then we call this point B. And then at this point also at the bottom, you can also draw a tangent at this point, and then trace the point to the x-axis and call it what? C. So this is point A, point B, and point C. Now at this point on the curve, and this point is called the maximum point. At this point, the y, the x is equal to 0. It is called the maximum point. When you cut out this, what you have is like a parabola facing down. The peak of the curve is called the maximum point. Then at this point, this is the point we call point of inflation. At this point. This is not a turning point. You can see the curve is going like this and then it continues. But at this point, it maintains a kind of linear movement at this point. Okay? It does not turn, but it continues. But at this point, we have a turning point. So here is called the point of inflation, that's point B, while this is called the minimum point. When you have a parabola facing up, the bottom is what we call the bottom root, is what we call the point of or the minimum point. Put this in mind. Alright, let me explain the nature of this curve. Whenever you are given a function, you're asked to find the stationary point of that function and also explain the nature of the point you're able to get. These are things that are required of you. Nature of the stationary. Okay, let me write it where you can see it. Okay. Nature of the stationary points. The first one, maximum points. Okay, at this point, which is at point A, at point A, at this point, take note, dy, the first condition is that dy over the x is equal to 0. That's the first condition. Now, to know, to be sure that that particular point is a maximum point, then 2 d square y over the x square must be less than 0. So at the point A, at this point, when you differentiate the curve or the function 2 times, at this point, the y square all over the x square will be less than 0. That's the second condition. Then for the minimum point, so point at point C, the first condition is that dy over the x is equal to 0. dy dx is equal to 0 at point C. Then the second condition is that d square y all over the x square is less or is greater than 0. This is less than 0, while this is greater than 0. So that's the minimum point. So at this point, the second derivative of the function is greater than 0. So that's how to find the nature, the true nature of the point, the stationary point. Then the next one, number 3, which is the point of inflection. Okay, the first condition at point B is that dy over the x is equal to 0. At this point, dy over the x is equal to 0. The next condition is that the square y all over the x square is also equal to 0. So this is the conditions attached to the nature of the stationary point. So whenever you are given a function to first find the stationary points, question will go further to ask you to find the nature. What type of stationary points are they? So if you can follow this instruction, whenever you take the first derivative and you're able to get 0, yes, it's a stationary point. Now you would like to know what type of stationary point is it. Then you look for the second derivative. If what you have is less than 0, then that point is a maximum point. The second condition for minimum point, that's the second stationary point. The first condition, as usual, dy dx is 0. So at that point, when you differentiate the function again at that point, and what you have is greater than 0, then that point is a minimum point. Then the last one, when you differentiate, definitely you get 0. Differentiate again and you still get 0, then the point is a point of inflection. Thank you for listening. See you next time. Bye.